Hello guys, in this video I would like to teach you on how to approach a Heaviside function, especially when they are saying draw the graph. Okay, so you will be given f at t and something like this. Okay, so the first thing, okay, we all know that when we are drawing a graph, the first thing that we need to know is that the coordinates of the graph, on how to find the coordinates of the graph. Okay, so here, in order for you to find the coordinates, you'll have a constant and also maybe any constant, and maybe then you will have the function which is f at t in terms of a t, of course, like this one. So when you have a constant, you just, and you have your restriction here, our, in this case, our restriction is t less than 1, and also t is greater or equal to 1. So you just take this 0. So if I may tell you or remind you that these values here, 0, 1, 1, 3 and 3, the x-axis values, and this one here are the y-axis values. So this 6 is from a y, and everything from here, as you can see, it's f at t. So f at t, it's like it is a y equal to. Do you understand? All right. Okay, so here you have a constant, so you just say 0 is to 6. Okay, so your x is 0 and your y is 6, and then you have a 1, and you will also have a coordinate which is 1 is to 6. Okay, so we are done here, and we have this function 8 minus 2t. So we need to take this one and substitute to t. So if we substitute, we have 8 minus 2, and we substitute 1, and therefore we will have 8 minus 2 times 1, which is 6. Okay, so we have 1 is to 6. You will notice this coordinate is the same as this one, so most of the cases these coordinates are the same. It's something like it is a continuous. Okay, and then we have this 3, so we need to substitute. So we have 8 minus 2 times 3. We substitute 3, so 8 minus 2 times 3 is 6. So 8 minus 6 is 2, and therefore here you will have 3 is to 2. Okay, so here it is a constant. Like I said, you just say it is 3 is to 4. Okay, so, and then you come here and draw your graph using your coordinates. So if you can see the y, the maximum value is 6, so we can end up here maybe at 7. So it will be 6, 5, 4, 3, 2, 1, and then we have a 0. Okay, so we don't have this one, so we can end here. And on the x-axis we have the maximum of number 3, so we can end at maybe 4. So 1, 2, oh sorry, so it will be 1, 2, and 3, and 4. So it is 1, 1, 2, and 3, and 4. Okay. Okay, so you go to your coordinates, 0 is to 6, you plot your 0 is to 6, but now be careful here. So if there is a less, or maybe let me read it like this: if it's t greater or equal, so if it's greater or equal to, it is a closed dot. That one, I think it's very important. It is a closed dot. And if it is like less, then it is an open dot. So like we have 1 is to 6, so 1 is to 6, it will be like this one. So it will be dot 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 dot. So it will be like this one. Okay, and then we have 1 is to 6. So notice there is a greater or equal to, so it is a closed dot. So which one is that one? So it is still this point, so we also close this one because of this one. So this one affects this one. Okay, okay. Okay, now we have 3 is to 2. So we have 3 is to 2. Okay, 3 is to 2. So we have unclosed dots here because it's only have we only have t less, not less or equal to. So this 3 is not included, but here it is included. 1 is included, 6 is included. Okay, so we have that point. And lastly, we have 3 is to 4. So which one? It is 3 is to 4, this one. But now there is a greater or equal to, meaning 3 is included here. But now it is greater than, so it will something look like this one. But now we can also connect here our dots. So it will be, we have something like this. So we connect here, you draw with your ruler, and you draw like something like this one, and then your graph should look like this one. Okay, so this is how you draw your graph. Okay, and maybe let's draw another one. Let's look at another one. Now let's say you have this one. So like I said, you need to substitute, so your value. So at t you substitute 0, so it will be 0 is to 0. So our point here is 0 is to 0, and at t you substitute 2, so our point here will be 2 is to 2. Okay, so here it is also 2 is to 2. So if you may remember, I took that I said that most of the cases these 2 points are the same. Okay, so you need to notice that one. So we will have a 4 is to 4 is to 2. So I'm expecting 4 is to 2 as well here. So we substitute a 4 here. So it will be a 4 minus 4, which is unfortunately is no longer the same. Okay, in this case is no longer the same, so it will be a 4 minus 4 is 2 4 4 is to 0. Okay, and then continue, and then we say we substitute 6 instead of t, so we'll have a 6 minus 4, which will be a 2. So we'll have a 6 is to 2. Okay, and here it is a constant, so we will have a 6 is to 4. All right. Okay, I think it is the first one that is the same, but I don't know. But yeah, okay, so then you come and draw your graph, the maximum one. So I won't draw on scale like I did before. So here the maximum is 6, so I'll say 6 here, and maybe let me say 6 4 2, then maybe let's say 0. It will look bad, but something like this. So here it will be 2 4 4 6, if I may use this one. I know it's not that appropriate. Okay, so we have our point, which is 0 is to 0. So we have our point here, and we have 2 is to 2. So 2 is to 2, it will be here. Okay, and we have our point 2 is to 2. So now it is included. So this one will affect the first one, and we have 4 is to 2. 4 is to 2. So it is not included. And then we have 4 is to 2, and we have 4 is to 0, and we have a 4 is included in this case. Okay, and then we have 6 is to 2, and we have 6 is to 2, which is something like this, and we have 6 is to 4, which is included. So it will be like this one, but now it is greater. So if it's greater, anything that is greater is on this side. Okay, so we construct our graph, so it will something look like this one. It will be like this, and it will be like this one. Okay,